Hello everyone, welcome to SynthFox channel. I'm Obrilis, and today I will be talking about writing your own firmwares and modifying official firmwares for the DIGENERATOR. It's a module that I recently released that is a hybrid digital and analog thingy, and it has an Arduino Nano compatible board in the back, and you can upload your own firmware to it. The USB port is broken out to the front panel, so I already connected the cable right there, my computer's USB port, and now I can power on the system. I already did that too. Be sure to not connect or disconnect the cable while your Eurorack system is powered on. Always powered off, please. And of course, refer to the manual for all the other instructions. But for now, I'll show you the template that I've been mentioning in the other videos in the overview, and in the upload videos I mentioned that there's a firmware on the website, and there it is, says download the generator firmware template. It's at this address. It's easy to navigate to this place just by going to synthfoxmodular.com and locking on from there. So you press this and you get a little zip archive right there. If you extract it, you will find a djr_template.ino out there. It's an Arduino sketch with a whole bunch of useful stuff in it, some functions, some definitions, and I'm doing this video in a single take just to mess around, show what can be done, give you some insight maybe, and the rest is up to you and your creativity. So first of all, there's this about section. So I encourage you to fill it out, because if you're going to share this online somewhere, by the way, share your stuff with us if you made something you think is nice and you'd like to share it with us. So of course, fill it out. Name, test, firmware, version 1.0, author, Aubrey, context, me, and so on and so forth. And then there's a whole bunch of defines here, which could be used inside the code. More on what exactly, how exactly to use them inside the code later on in this video. But first of all, we have a whole bunch of in-gate something defines, in-gate 1, 2, 3, 4. This checks if there is a gate at a particular gate in input of the module. So if you want to check if there is a gate on gate 1, you say if in gate 1, do something something. Also, there is this out gate on, off, and flip function. Definitions. So out gate on define lights the output gate on, the LED of course. Out gate off turns it off, and out gate flip inverses the gate output. So if it was logic high, it will become logic low, and vice versa. The character definition here is for reading the sum of the character knob and character control voltage input. Its resolution is initially 10 bits because the built-in analog to digital converter is 10 bits, but the 2 bits are very noisy, the least significant bits. And also, most of the firmwares I made use byte or unsigned character as their main variable type, just 1 byte long. So it makes no sense to have it be 10 byte long. I decided to have it be just 10 bit long. So it's 8 bit long. It's 0 to 255. The resolution is 8 bits. Finally, there are these opt A and opt B checks. These are similar to in-gate, but for the option switches and gates, gate inputs. So then we have some global variables. These will be accessible throughout the code. I defined a 2 byte long one here called RND. It's for the random generator, more on that later. And this is the 1 byte long variables. There's just one called counter. Don't mind this stuff. There is this auxiliary functions section here, which is very important. The most useful here, of course, is the DAC function, which you call every time you want to put a value to the digital to analog converter. So you just put your unsigned character or byte or uint 8, so unsigned integer 8-bit long here, 0 to 255, and it appears as a voltage at the DAC output. Now, the DAC output is AC coupled by default, so there's a capacitor out there which tries to block the DC component of the signal. It's best for audio usage, but it's totally possible to generate control voltages with the degenerator. You just have to switch the pin header on the back of the module to make the output DC coupled, and then this output will be actually DC coupled, useful for CVs. Then there is this function RND update. So every time you want to roll a new random value, you say RND update. RND is 2-byte long, so it's 16-bit. And you want to cast it to 8-bit long if you want to use it with other 8-bit variables, most of the times. But that's easy. It's nothing hard. I will show you how to do it a bit later. Then there are... oh, wait. There are all sorts of other nice functions that are sometimes very helpful. And then there is this section, interrupt handlers, which is the most important one, because there is this on VCO cycle function. It gets called every time the internal VCO, the volt per octave one, the cool one, clocks the microcontroller. So all the stuff related to the VCO pitch should be carried out here. Then there is this on gates interrupt, which gets called every time a gate turns high. So if we receive a high gate on gate 1, this function gets called. If we keep having a high gate on gate 1, and while it is high, we also get a high gate on gate 2, this will also get called. So it's like a trigger, a function that's triggered by any of the gate inputs. Then there is all sorts of other stuff. This is the setup. So this code is run, it's an Arduino default thingy. This is ran on the beginning of the microcontroller power cycle. The code just is run just once here. And then there is this void loop here. So while it's not handling the interrupts here, it will do whatever is in the loop over and over and over again. Okay, so there is something here already in the on VCO cycle. It's a variable called counter, which we declared earlier. It's declared by default here as uint8 underscore t, which means unsigned integer 8-bit, which means it's 0 to 255, just 8-bit variable number. And on each VCO cycle, we add 16 to it, so it was initiated as 0. One VCO cycle it will be 16, then it will be 32, and so on, until it reaches 240, at which point if you add 16 to it, by usual human logic, you would get 256, but that's not a number you can represent with an 8-bit variable. The maximum value is 255, and if you add 1 to 255, you will actually get 0, not 256. And this is very useful in this case, because when we get 240 and we add 16 to it, we will get 0 and the cycle will repeat. And then, ignore this for a second, we have DAC counter. So we push whatever the counter is to the DAC. Let's upload this firmware. I hit the arrow here. We'll be compiling it for a while, and then it will upload it to the DIGENERATOR. And you see the DAC output connected to master output. It says done uploading. Let's check out what's going on. So as you can hear, we got a nice Sawtooth going on, and that's because we add 16 over and over until we reach 240, and then we drop back to 0, so it goes in a Sawtooth-like fashion. And then there is this thing here: if counter equals 0, outgate flip. So we use this outgate flip definition here, and we call it every time the counter is equal exactly to 0. This happens only once per the whole Sawtooth cycle, and it will toggle the out gate on and off on each Sawtooth cycle. So one cycle it will be on, one cycle it will be off, and so on. Which means it's basically a sub-oscillator, the main frequency. Let's hear it. Now I have to attenuate the gate output quite a bit because it's very loud, but you can hear that indeed is basically a sub-oscillator now. But what if we want a triangle? What if we want a triangle instead of a Sawtooth? Let's try doing it. So first, let's think how to do it. So we have a rise, then we have an immediate fall because this thing robs up around the 255 and gets back to 0. So we can detect if counter equals 240. That's the last value before it goes back to 0. We should somehow make it slide back to 0. And when it reaches 0, else counter equals 0, make it rise again. Well, this plus is sort of weird here because it will be adding anyways. So we have to somehow detect, should we add or subtract? Because when we reach 240, we should be subtracting. So let's move this here and say if sign equals true, then yes, else say this. Now we didn't declare the sign variable just yet. We will do it in a second. So first, here to make it slide back to 0, we set sign equals false, of course. And here, sign equals true. So just to finish all of this, we go all the way back to the variables, add another type, bool. This is a boolean. Sign equals true. So we begin with the true because counter is 0 and we should start rising. Basically, sign will be true, then it will be adding, and when it hits 240, it will set sign to false. And then if it's false, so not true, it will be subtracting until it reaches 0. Then it makes the sign true again. Let's see if that works. File, upload. Should be something like a triangle now. And indeed it is. Okay, now I am happily turning this knob right there on master output, but what if I want a volume knob right on the degenerator, and we have this character knob hanging out here doing nothing so far? So let's try doing a volume knob. So let's make a variable here called, I don't know, temporary. Let's say byte temp equals counter. So we just make a copy of it. Okay, we want to make a copy of it because counter sets the whole wave. It takes part in the logic of flipping the sign, so we should not really mess with it. But we can say temp equals counter, and then we DAC temp, and then in between these two, we can do pretty much anything we would like to with the temp variable. And byte here is also unsigned char, and uint 8_t. It's all the same thing. Unsigned character, uint unsigned integer 8-bit, and byte is the same thing. Use whichever you like. I mostly use this one. So what I write here now is, let's just try doing the temp minus equals character. Now, this may make things a bit slow, because, and I will explain in a second why. As you can hear, now it sounds like, and that's because the character thing is a call to the analog to digital converter, and you shouldn't do it every cycle of the VCO. So to optimize it, we should create some parameter here, some variable. Let's create here a variable called, for example, volume equals 0. So this volume here, this will be our volume, and we put it here instead of the character. So minus, I mean, it's logical. Let's subtract this, and then the more our character knob is, the bigger this volume or character will be, and then it will probably fade away. We will see. And then this volume is 0 right now, and nothing really updates it with the character thingy. So we will say here on if counter equals 0, also do volume equals character. So now it only calls the character function the character define only once each cycle, not every step of the cycle. Most likely will improve the situation. There is something. Quite what we wish. Let's remove this temp minus equals whatever. See if that works without it. Yes, it does. So this character is not eating up the time anymore, but somehow we don't get the volume action, and that's again because this temp right there is a byte or unsigned character or unsigned integer, 8-bit long, and if we subtract something from it, it basically will just wrap around and nothing good will happen. It will not act like a volume control. So for that, we have a really nice function here, sub if not neg. It means subtract this from this, but only if the result will be not negative. Otherwise, it will be 0. So it's like sort of a clipping byte subtraction. And we can use it here. Temp equals sub if not negative temp, and we subtract volume. Let's see. There we go. This is way more like a volume knob. It still does a little bit of tonal effect because essentially it sort of clips the triangle into the 0 area. But usually the volume works the other way around. It's not the full volume here and 0 volume here. It's usually vice versa. Try using this little symbol right there. This means not. We'll invert all the bits in this variable. Work. Oh yeah, there we go. We just inverted the entire thing, and now, would you look at that? It works like a volume knob, and most importantly, we could use a CV input to automate this volume here. So for example, LFO What about the other stuff? What about the options? I can use the option A to allow updating the DAC. As simple as if opt A DAC. Now, I have to turn this opt A on, and of course it could be turned on externally. Okay, and for the last thing, let's make something with a gate. So, and the random generator. So let's do a random update here to update the random thing. And then if in gate 1, so only execute this if a gate has been received and the gate 1 is on. Now mind me, you will have to write a more complicated code to actually detect if it has been in gate 1 that has been triggered just now, because in this configuration, if we received a gate in gate 2 and the gate 1 is still high, this condition will be true. So you will have to do a bit more detection if you want the gates to be treated like triggers, but for now this will suffice. And I will actually move this here, random update. Then I will make a byte, again temp. It's not the same temp as here, it's temporary variable. So this one exists only in this scope. This is only here. So here I say byte temp equals RND, actually. This will make this RND fit into this byte by just cutting off half of it, because this one is 2 bytes long, so it will just take 1 byte and put it into the temp variable. And we will say, what can we do with it? We can make another variable actually, and we can just say XOR here, XOR, for cool effect, make it global. Again, I just came up with it, so it's not the best idea ever probably, but we'll do for demonstration. So I will say XOR equals 0 here, and I will do a little funny trick here in the onVCO cycle. I will put here temp equals counter XOR the XOR variable. Okay, there we go. Now this temp will be assigned the result of XORing, exclusive ORing, the counter and the XOR variable, which will be sort of like a weird effect value. And we will put it here as random on in gate 1. So each time we get a gate and in gate 1 is on, we will update randomly this XOR variable and get a different kind of flavor here. Let's see. Most likely it will sound really abrasive. What? What do you want from me? I think it's reserved. So let's call it FX. Actually, I will just this for FX. Place all. No. Oh yeah. Oh. promised, I will also talk about modifying official firmwares. So let's see. There's this grid VCO here. Let's roll with it. And thing is, there are these effects here that you can choose, but also you can just write your own effects. So let's choose no effects here for this. Hit generate, copy everything, paste it right there. And first let's just load it to correctly. Seems to be working just fine. And the opt B now is on, which means we can go and check out the code. And if we go to on VCO cycle, which is where usually all the fun happens, go to frame counter update. So it's a very similar setup to what we just did. So there's this by temp equals character, something, so on, so forth. Gate output, there's this effect. And we selected no effects for opt B up position. It's also a very similar thing to what we had before. There is nothing here, but there's an effect here. So we could do something very basic. There is this effects variable, which I assume is, yes, there should be somewhere around effects equals temp. Yeah, so it's also basically the same as it was in the from scratch example. It's done just once per wave cycle for effectiveness, and we can use it here. For example, frame equals frame plus effects. Let's see what that does. This is some sort of a weird distortion, warp distortion or something, but that's not quite nice. So let's try the XOR. We have it. You can write all sorts of stuff here. So for example, I can write R&D update, and then I will write frame equals frame bit shift by 1. Read about bit shifting, please. But this basically means divide by 2, but faster. Plus R&D bit shift 8. This is quick way to cast it into a byte without really casting it into a byte. And effects. So what I'm doing here is I'm halving the value that we want to output, and I'm adding some noise to it, this random value here, that's also ANDed with the effects value. So the higher the effects value, the more bits from this R&D will get through. Let's check it out. At least supposedly that's what it should do. And of course this R&D update here fires every cycle, which is fine for generating some noise. Let's see. So now the character knob sort of acts like a crossfader between noise and the tone, which I think is really nice. And of course I encourage you to experiment not only with the effects but with everything else. Here the code is open, you can check it, try to mess with it, see what sticks, what does not. And I hope you have a lot of fun coding for the DIGENERATOR. If you still have any questions, please drop them into the comments section or to our email address. I've been Obrilis. Thank you for being with me today here on SynthFox channel. Subscribe if you don't want to miss out the other updates, and see you next time.